Welcome to Spring LIB.
In this problem, we have a little gear train here. Oops, I'm going to draw on it. Okay, so we have an input pulley here that's going at omega A or 600 RPM clockwise. So that's 62.8 radians per second. We have the radius here is 2 inches. The radius to this is also 2 inches. The radius out here is 4 inches, and the radius of this one is 6 inches. So this is like a compound gear here. So we have 2 gears attached to one another. Now, let's see here. Just from gears, we know the angular velocity of B, which is in this direction, is RA over RB times omega A. And plugging, this ratio here is just 1/2, so that winds up being 300 RPM or 31.4 radians per second. Now for C, we know that because this gear here with the radius of A is driving C, we know omega C is RA divided by RC times omega B. And plugging in from here, we get this. So we get RA squared all over RB plus R times RC omega A. I plugged them in. I used inches here, which is fine because the inches all cancel out. So we don't really need to convert these to feet because the conversion factor would cancel out because this is just a non-dimensional value here. So this gets, basically, we get 1/6 of omega A, which is 100 RPM or 10.5 radians per second. Now, for the acceleration, we want the acceleration, what did they ask us for? Angular velocities of gears, the acceleration of gears of points on gears B and C. So on B, I'm assuming that they basically are saying that at the acceleration at a point on the outside of it. They don't actually say that, but I assumes. Oh, the points which are in contact. Okay, so these, yeah, I drew it here. These 2 points here. They want the acceleration of those 2 points on each of these gears. So the acceleration here is RA. Okay, so the radius from the rotation axis times omega B squared, and again we can substitute in that. This winds up being RA over RB squared, which is 1/4, times RA, which is 2, and again I'm using inches here, so our result's going to be in inches per second squared. So and then we have omega squared. So we get 1,970 inches per second squared, and that's going to be in the radial direction, which in this case is in the minus y direction. Now for this one, we have RC, the radius, the distance from the rotation axis to the point, times the angular velocity of this pulley squared. Again, we can, plug this, use this expression here, plug that in, and then we get some cancellations. And again, I'm gonna keep the inches here. So our output is going to be in inches per second squared. So we get 2 to the 4th divided by 4 squared. Actually, those cancel out. Divided by 6 times 62.8 squared. Plugging everything in, we get that is 658 inches per second squared in this direction, in the positive y direction, or in the negative radial direction from this axis.